Now let's look into your practical exercise. And in practical exercise we have to implement several interfaces. Some of these interfaces are given already in this package activity 06. Some of interfaces come from Java language itself or Java libraries. So here we have two different interfaces, humanoid and alien. And if you want to have some backstory about it, then here is simulation of different life forms or simulation of some universe. And interface for humanoid somehow describes simplified model of humans and other humanoids. And the interface for alien describes different kind of aliens. And we need to implement these interfaces in concrete classes. And the implementation of humanoid interface in human class is quite simple. We need to create new class in this package called human. Superclass is object, but implementing interface is humanoid. And finish. And here this code generator generated stubs for all implementing methods. But to implement them, we need to look into more details about this interface. And if we look on this interface, okay, let's first look here. So we need to implement approximately 5 different methods. Eating process, when humanoid is hungry, then it may eat integers, object-oriented integers, not primitive types, and gain weight as much as it has eaten. So value of this integer means also how much weight this human or humanoid gains. And then you can get weight, which means birth weight, initial birth weight together with total weight. It returns string, integer. Then is alive, it returns status. Is this humanoid alive or dead? Kill himself. Kills this particular humanoid. And vomit means vomit, eaten, food, back, and losing weight. And for simplified model, everything what is eaten is vomited, and weight is back to initial weight after that. So that's what is behavior what needs to be implemented. And when we implement it, important part in object-oriented approach is to analyze your requirements and decide how many things you need to remember, how many things may change state. And what I see here is that first thing what we need to remember is this humanoid alive or dead? And because that will be state for each particular human or humanoid, then of course it is instance variable, no static keyword here. Every new human which will be created will have its own state, boolean alive. And my recommendation here is that when you create these instance variables for each particular instance of this class, never use object-oriented variables here, because you will know precise meaning for this primitive type from structure of your object. And my recommendation is that you are free to use wrapped object-oriented types when you exchange data. For example, when you pass arguments to method, or you return them from method. But when you need to store them, there is no need to have additional data put inside your object, because you know what this primitive type will actually mean from internal structure of your object. And then another state what you need is either integer weight or integer stomach. And I think we don't need both, because if we have at least one, we can calculate another. And here preferences are up to you, but I think that calculating content of stomach makes business logic a little bit easier. Because if this is 0, you eat something, you gain content of this eaten thing. When you vomit, stomach again is 0. So otherwise you start with some initial weight, gain it, and then go back to initial weight. Only thing which will be more harder to calculate is total weight. We will need to add this initial birth weight at the beginning, but I think it's easier to deal this business calculating content of stomach than calculating total weight. And I think we don't need to remember anything else, so this is only needed structure for our implementation. And then we can start to implement these methods. So about eating, so if we deal with stomach, it's very simple. If stomach is empty, and here automatic unwrapping happens. Value of this primitive type inside this object-oriented integer is taken and assigned here to our primitive integer here. So vomiting means vomiting integer back, And here, if we decide to use just primitive type for integer, we cannot just say return, I think. Actually it works. But even if we can do this, we still have a problem, because this stomach should be emptied first, and then it should be set to 0. So if we return, we cannot say is 0 after that. So one of things how you do is introduce proper object-oriented integer temporary value, then empty stomach of this human and return this temporary value. And because it's local variable, I immediately made it as an integer. It looks like this also should work. So then I think it is wrapped into integer automatically. So use whatever you like. So this probably is more clear for beginners. So here, one of wrong things we can do is to save the state alive or dead as strings. Because for Boolean, even it takes entire byte just to store one single bit, 0 or 1, is better than storing string like alive or dead. So when we deal with data, never mix two different things, actual data needed and representation of data. If actual data needed are just Boolean, use Boolean. If this Boolean needs to be represented with some funny string or whatever, represent it as a funny string, but do not store it for 1,000 or million times here for each particular object. And therefore we just need to represent it as a string here. If alive, return alive. Or return dead. And some would write else here, but I always make code shorter as possible, and if I do automated proper formatting, I see that this will be returned only if alive, but everything else will be returned dead. And when this human tries to kill himself, so alive is false, and return dead. But what I don't like here is that I have reinvented myself. I have two literal values, dead and dead here. And if somebody will say that it should be changed to dead, then I would need to change it in two places. And that is bad design. If one single requirement changes, you need to change it only in good, well-designed software. You need to change only in one place. Other not so good approach would be to introduce something like static final string alive, but that will just take, I know, and then use this variable here, but I have not told to you, but all literal values are checked for uniqueness, and even though if you use literal value in many places in your code, actually in runtime it is stored only in at one place, and every time you refer to this literal value, you reuse the same value. And therefore, I will not reinvent it myself. I will use isAlive method to retain this status, and if it will dead, it will retain dead. And here we are doing small coupling, and coupling in general is bad thing, but if it's just little bit of coupling and code reuse, it is still good thing in total. What would be bad thing is something like this. That instead of making it false and then it is alive, you would do it in wrong. Okay, I will not talk about this. So that's about this and get weight, because I decided that my business with stomach will be easier. Business with calculating weight is harder, so we need to return this bar weight. And of course I could use literal value here too. 2 plus. And it would work in this particular case while interface is not changed, but when interface will be changing, this literal value 2 will break, and therefore I need to refer to it dynamically, that if this interface is changing, my implementing method still will be working. And now I have implemented all the methods required by interface, but what I have not implemented is nice toString method. And here is hint for implementing this. Nice toString method would be something like this. So class name for here is human, I think. And because I decided that my weight will be more complicated, I could write something like this here, but then again I'm reinventing myself, because this calculation is already done in this method. So proper way to say what is current weight is following. And I think that this particular class is implemented. I don't know what tests have. Again here. Tests are together with mine folder of this, not in tests. I think I made this notice for. I think it will fail, because I think first we need to implement all needed classes. Yeah, and here somebody writes in comments that to make it future proof, but a little bit more complicated, we can do something like this. Instead of fixed literal value, we can say this. Then if we will extend it to something else, we will not need to change this literal value to anything else. We will not need to override this toString method to something different. So if you like a little bit more complicated code, but you know how it will work and what the benefits are. If you know what are benefits for more complicated codes, then you can write more complicated code. If you don't see any benefit for them, then why bother? So first we need to implement all classes to check how this works. So next task is to create Martian class. Martian class is more complicated because it implements humanoid and alien interfaces from the same package, and also it needs to implement clonable interface from Java. So we create another class, call it Martian, and implementing interfaces are humanoid, alien, and clonable from Java runtime or GRE, and finish. And one part of business here is similar. Bear's weight, eating, vomiting is approximately the same. Only difference is alien is not so picky what it can eat. And alien can eat object-oriented integer or integer wrapped into integer class, humanoid or alien. So these three different things. And when it vomits them, of course it vomits these things back. And it gains weight depending on value of this integer or weight of these other eaten objects, and if these objects can be killed during eating, then these are killed. And different behavior for kill himself, because if you check is it alive, it says I'm immortal for Martian or alien, and for kill himself the same, so cannot be killed. And now again we need to think how many states do we need to remember. And if we think about alive or dead, my approach or opinion is that we don't need to remember anything, because we need to remember anything only if this state can be changed. But if something is immortal, so we don't need to have some bit flipped from alive or dead, because it's always alive, so no need to store any value for that. Because we need to store a value only if, for example, this state can be changed and this state can be changed. But for stomach we have more complicated thing, because it will not work if we will implement it with just primitive integer, because when we move it back we just don't need throw back value of integer, but we need to throw back either humanoid or alien or integer. So stomach business becomes more complicated, and because common denominator or common class for integer, humanoid and alien, I think is just Java object. And when we eat, so how do we eat? If, and now it's not empty or null, but null because it's object. And here we see, oh, wait a minute, some two different but similar methods. And here I'm reinventing myself, or I'm duplicating code again. So only difference here is that one it comes from this comes from humanoid interface, and this comes from alien interface. And only difference is that here integer can be passed, and here any agile object. And we cannot just throw it out because now compiler is not happy. But we also shouldn't reinvent ourselves and duplicate code. And question is, how can we use one of these methods to use another? And you see that object actually is generalization of integer, and if we generalize integer to object, we can still use this method. So we can use something like this eat, but here we upcast this integer food to object. And now, if it is just an integer, we overgeneralize, not overgeneralize, just generalize integer to any object and use only this implementation here. And business with vomit is similar again, because we need to nullify our stomach after that. We first need to remember it temporarily. And here for is alive, we return literal string here. And here, again, I do not reinvent myself, but I just call is alive. So a little bit of coupling, but that's bad thing, but good thing is that I'm not reinventing myself. And here, it's about coupling and consistency. Behavior would be absolutely the same if I would return literal value I'm immortal here, and I would call method kill himself here. But readability and maintainability of this would be much worse, because it's not so obvious. You always need to implement it in the most obvious way. That if somebody just checks status of this object and calls is alive, it actually kills this object. It's very confusing, especially if you look what this killing object means is that it actually does not kill itself but just return I'm immortal. So here business logic is strange. To check status, this object needs to kill himself, and this kill himself actually works in such a strange way that it doesn't kill himself and returns I'm immortal. But if you do it in opposite order, now business meaning is much more obvious and easier to understand. If it's alive, it returns I'm immortal. If you call Kim kill self, it just returns I'm alive, is alive. So even though behavior is absolutely the same, this implementation is much more easy to understand, much less surprising than opposite implementation. And for get weight, So again, we could use literal value for alien, which is -1, but proper thing to do is get initial weight plus. And here our business becomes a little bit more complicated, because it depends on what is inside stomach, and we need to check if, okay, we will introduce something int stomach weight, just, okay, let's call it long, but easier to understand. So stomach weight is I think it will work. Stomach is object, and this will work. And we can say else if we like, but I tend not to use else if these are exclusive. And here business between humanoids and aliens is the same, and I will do some shortcut here. In general I would need to have 3 different cases, but if I say instance of humanoid, then the stomach weight is of course, and then we need to get actual weight for it. And why this doesn't resolve to this, then it is alien. So here, instead of 3 different cases, I made only 2 different cases, because in this case both Martians and humans are humanoids, and if I use humanoid as a common interface, I can call getWeight either for Martian or for human at once. So here again I'm using this polymorphism principle to deal with different but similar things in the same fashion. And again, as we see here, everything what needs to be to get it compiling is implemented, but that's not it, because first we need to implement the string, and if we make the string dynamic, then we can shamelessly copy paste this code, and if we would like to make it shorter, One of things would be to make the string as a default implementation for example, for humanoid interface. But I do not know will it actually compile if we will say that it is default. And therefore we will just have copy paste some code here. And then, okay, we can run some JUnit test here. Something is missing for human. Integer human vomit. We have implemented something, but probably something different. So where is vomit? Here I generated this code using generator, and it created as it is required that it returns object. But JUnit tests actually want to be more precise, that we return integer instead of object. And we can do so, and everything still compiles, because now we made output more precise, or subtype of just an object. And so we don't need to change anything just to make this implementation more specific output. And what's wrong with Martian? So this method clone is not implemented. So about clone, this is separate and quite interesting story. And let's leave this project for now, and let's go back to test project. Talk here is about clonable interface. Well, let's first check theory. I'm reading here chat, and Janis is writing that if you make alive a string and make I'm mortal the value, then you call the string as a return and you can escape coupling and code duplication. So that's one of things you can do. And for example, some of code quality checks for Eclipse, that would be plugin called, I think, round cube. And that's what it recommends, that you introduce these common variables for such literal strings and then just refer to these variables. But I do not fully follow this approach because I don't like jumping in the code. For example, what we can do here is, as I told you, not in interface, but in and then you just return it here, and here, and that's what actually different kind of code quality tools suggest you to do. What I don't like about this is that now I have created explicit static structure, and static structures are considered not great thing. And also I need always to look on particular values here for these common variables, and probably these are usually put in top of that. So you can use any implementation you like here. It's up to your preferences. So complexity in total is approximately the same. What is nice here is that you just return variable. That's good because it's shorter. What's not so good is static structure here, and you need to always refer to variable to check what its actual value is. So readability is a little bit less, because remember, if you use literal strings, then these are always located only in one place. So readability is good, but it still doesn't take more virtual memory than such variable here. Yeah, now back to this clonable interface. So for this clonable interface is interface which indicates that object.clone method actually creates clone of this object. And for example, let's implement solving. Let's generate it. Too much code to write. And then we can try to get clone of this object by calling clone method. And if we try to run it, what happens is we just get clone not supported exception. But if you say implement and we also will implement a string method. See actual values. And what will we see? If you say that your object implements clonable interface, you can very easily get clone of this object, which will see that this object is not the same as that object, because if you compare them exactly by references or as primitive type, so here reference to this object is compared to reference to that object. So these are definitely located in two different places, and we can look it inside debugger as well. So we see that identifier for test is 22, but for test 1 is 23. So these are completely different objects, but their values inside are same. So we created different object which is precise clone of that object. But problem here arises that this clonable, when you implement it, if you have deep internal structure, and then we will implement the string method. And we see that now there is object inside object, which is business term. Actually there's object referring to other object to the same type. And here is its first level internal structure till to this place. But then here is second level of internal structure where object refers to other object. And we need to have object inside object which is not clonable. What can we put there? Object. Okay, so problem, and here it depends on the versions of Java. In older Java versions, it worked in the following way, that if you just declared that your object implements clonable interface, it still just throws this clone not supported exception. Only difference was that clone was a protected method, but if you used it, then you could expose it. I can't show exactly. So here I'm still working with objects which supports clonable interface correctly, but as soon as you have object inside object in deeper level which do not implement clonable interface, this deeper structure of your objects will interrupt, because these are not clonable objects. And how can I prove it to you? I can prove it to you in following way. So So very similar objects, only difference is that one is clonable and another is not. Okay, maybe this will help to us. So if this works properly so well, then only thing we might try to do is here to declare that our Martian class implements clonable interface. And then only thing we need to do is to expose this clone method publicly. And let's try to do just something like this. And maybe then we'll see where our problem is. Martian, somewhere here. And then something like this, maybe it will work. Something is default value for boolean, of course, is false, so we need constructor. Here there are two different schools of thoughts. You can always do it in a following way, but it is not recommended because it's not so dynamic, and therefore that one thing. And other thing is that we can talk about optimization and lazy initialization. And therefore it is recommended, if you need to assign some initial values, that you do it inside constructor. And here we have another problem for we are not killing. Where is Martian? Where is eat? item. So we need to do more things here. So we can kill only humans, and therefore I will just say if it's human. Is this understandable to you? So I dynamically downcast it to human, and I will be able to do it because it is instance of human and kill himself. I do not reassign it to temporary variable here. And so here we see its problem, object is not cloned properly, address is the same. And super is Java object. So where is the difference between my simple example which actually worked and this example which doesn't work? We need to what is about these interfaces? ION string to string to string to string. No, it's not told here. Because super means we are referring it to object and that is not clonable. And if we don't have it, then we need to have such method. Okay, so in theory, you may analyze it by yourself, that in more modern Java versions, if you say implements clonable, it actually has this default implementation of clone method, which even works in simple cases. And if you will find out how can you reuse this already implemented clone method, and how it exactly works. So here it's just clone not supported exception. Where this nice implementation actually comes from, no idea. And problem is that particularly for Martian, it still doesn't work as I would like it to work in this simple scenario where it actually works. Test clone, and here just throws clone not supported exception. If you will resolve this puzzle, tell it to me, but I know how to resolve this puzzle in old school approach. So in old school approach, you actually, when you implement this interface, you are claiming that clone is working, and particularly for clonable interface it's called tagging interface, because you don't need to add and implement any more methods than you already have in your object. But tagging interface is like honorable badge you assign to some well-behaving class. And in this case, we add this honorable badge. At least currently we are claiming it. We are not earning it. That objects of Martian class will be properly cloned. And particularly for Martian class, cloning is hard because in stomach of Martian, another Martian may be. And that means if I create Martian 1 and there's Martian 2 in stomach of it, and then Martian 3, blah blah blah, and Martian n, and then inside of it is either null or human, and something in its stomach either null or integer, or null, human, so all these cases. So if when I clone it, I need to create proper clone, Martian M1 with Martian M2 in stomach, Martian M3, Martian N1 in stomach, and with its stomach either null, or another human with stomach either null or integer. So all these data structures need to be replicated. Otherwise, this claim is not earned. And how do we earn it? First is we need to implement such method which doesn't take any parameters. And we could implement everything inside this method. But if we would implement it inside this method, okay, now for now to make it compilable, then problem is that we would need to use bad coupling, and bad coupling is that when we do this cloning, not in this window, in this window, we need to know what current Martian is. So we start with current Martian 1, then we go to stomach and current becomes something else. And how can we do this? If method takes no parameters, doesn't return anything, we need to create something like here. Current stomach, and then here, when we say get stomach to go forward, we put it there, then get stomach and go back. And this is typical example of bad coupling, because when we look on method, we think it doesn't need any parameters here to work, but actually needs, and it takes this parameter from here. And then we also have problem with this, that if it belongs to, we actually are jumping from Martian to Martian, which are completely different data structure. And if we create a current stomach variable as a part of Martian, then current stomach is different for this Martian, different for this Martian, etc. One of the things we can do, we can introduce static structure, which belongs to the class, not to the Martian. But then we have problem what will happen if it will be happening in multiple threads with many cloned Martians. Then all these many concurrent threads will refer to the same static structure belonging to the class. So in single thread like this would work, but as soon as we start cloning with concurrent threads with many Martians, of course we just now have only single placeholder for current stomach, and it will not work. So don't do this. Proper thing when you need to traverse through data structures is to use recursion. And recursion means you call the same method again, but take different parameter for next iteration, something like this clone. And here you do something like this current get stomach. So you get stomach for it, or say something like and here some blah blah blah, and then you clone starting with not current Martian but Stomax. And this is proper way how do you traverse through the data structures. So you call the same method again, probably in infinite loop, but if you go properly from stomach to stomach to stomach to stomach, this will not be infinite loop until you will reach end. And here, because we need to implement method which doesn't take any parameters, and here we need method which takes parameters, this means that we need to have some entry point for this. And therefore, we start entry point from following. We return clone starting with current object with this Martian, and then actual implementation is this properly recursive approach. We clone object, go to next object using the same method until we are done. And here, this current object may be Martian, maybe human, maybe null or integer. So many different cases. And we will start it implementing, and when we do with recursion, usually you start thinking about end of loop. And end of loop, the easiest one is if this current object is null. So we started with calling clone method for Martian, but then we get stomach, get stomach, get stomach, get stomach. Initially, what actually will pass, we will, and here again, you need to remember that it's abstraction to say that the object or instance of class consists of data and methods, but actually data and methods are completely different things. Data are somewhere in stack or maybe heap as a data structure, but methods are in class definition. And even though your current object is like human, what you are actually calling, you still call clone method from Martian class. And here, this distinction between methods and actual data is very important. So don't get confused that if current object is like human or integer or null, we are still executing clone method coming from Martian class. So that's important here. So we are still always re-executing clone method from Martian class, but this current object, which may be happen here, may be different object, not Martian, but anything on the world. And so if current is null, and of course you need to write it properly in Java. This is easy. So we have implemented one of easiest cases. We reached end of stomach inside stomach inside stomach, or object referring to object referring to object referring to null. Probably next easiest one is dealing with integer. Then we need to return new integer. But we need to get value out of this. And in this case I will not afraid to introduce temporary variable. And we need to create new integer with the same value here. And I don't remember how can I do it. This will be source. This will be target. So somebody, if current is integer, why do you need new one? Because we need to clone it. We cannot pass it as is. Only nulls are the same nulls. Everything else is needed to be cloned. And even though integer itself is not clonable, we need to clone it because it's inside our Martian object. Value of. And here we can say, okay, now I remember, we can do something like this. So value of is again something like this factory method. It belongs to the class, it's static, and if we pass some value here, it will create new integer with value of that integer. And if it's only one single line, then we can write back to this. So that's this case at the end is solved. And of course, if it's null for human, it's solved as well. So this is first. This is second. Now about humans. So if current and I do not know, can I put them together like humanoids and aliens or not? I will start with specific class like human, and then I think I will need temporary variable like src, which needs to be cloned, is human of current. So I downcast current to the human. Clone, I will call it target, is new human. And then I need to clone, because human is not final step of my loop, because it may have something inside stomach of it. And therefore, for target, stomach is source, is clone, src, stomach. Doesn't look very nice, but hopefully it will work. And it still goes to this method. And then, so that would be this part for human. And then is Martian. It is very similar, And maybe we will do some optimization later, because I do not know, as usual I don't remember details for these exercises, and don't be surprised, you also will not remember details after a few weeks, and not counting half a year. If it's Martian, then Martian. Martian, Martian, and we can cast it to Martian if we like something like this. And now we have compilation error, because we still need to return something like null at the end, because otherwise compiler doesn't understand. But here we see return null, here we see return null, and then that means we can do first step of optimization. Here we do following: if it's not null, deal with it, otherwise it should be null, at least in our primitive, not so primitive, but in our case, and we return this. So I already did one first step of optimization here. And we can try to run JUnit test. And something is still not initialized properly. This is end. And here I do recursion for clone of stomach. So something is not right with my implementation, but I don't know what is not right, and we need to do some tests. Well, let's start with humans. So nothing is weighted. And I need to wrap it around with dry catch. So that's what we see in Martian, M1. Then when we try to clone it, oh, I already see what is. Return target. Oh, and sometimes it works, sometimes it doesn't, and it means that for some cases the implementation is working correctly and sometimes not. What does it mean? It means that here 1, 2, 3 and Martian is forced case. Some of these cases are okay if end result or end stomach is null or integer and human, and for some cases it's not okay. And so let's do manual tests here to check, or maybe we can review code. I will do manual tests, it's easier for me so to understand what's exactly wrong there. Actually, we can do add breakpoint here at the beginning of the cloning. So source stomach null, target stomach null. And we can do following. Print it out. And maybe with line break to compare them easier. So as far as I can tell, this looks good to me. Yeah. That's again one of things you do improperly if you copy paste your code. I think this may be actual problem. Yeah, and to test it out manually, let's for example eat new human. Yeah, I think that was my problem. Now we may think a little bit about optimization. When it works, you can think about optimization. I already did some premature optimization here, but I think it was not big sin. And can we put these two things together for Martian and human, like looking on this like a humanoid? I will leave this up to you. Vomit for Martian, vomit. So here, principle is similar as vomiting integer for human, because we need to return what was eaten, and then after that stomach should be nullified. Easy approach how to do is add some temporary variable, then set original value of stomach to null, and then return this temporary variable. This is quite standard approach. How do you do this? So, and here I left it as your classmate suggested. Instead of calling method returning the same variable there. And if you don't like this, you can just always return literal value, but then you will have literal value several places in code. So readability will be better, maintainability will be worse. And also I will leave it up to you to understand why in some simple case, when only thing we implemented was clonable interface, actually we got this proper clone here, just by declaring that it implements clonable interface, and it didn't work in such way with up to Java 8. It was introduced in some newer Java versions when this project was switched to Java 11. That was half a year ago. So if you will understand why this worked and it didn't work for our Martian, then this code may be even shorter if we would know how to use properly this interface, this clone method. So I'm surprised here, because when I decompile this class and I see clone, so here it's still just a declaration of it and it throws clone not supported exception. How exactly it works, when exactly this cloning works from inside the Java libraries, I don't know. But this is old school approach which works. Question may arise, why do we need cloning for objects? And answer is following, that sometimes it is beneficial that you create completely different object with the same internal data structure. An idea is similar to certificates and documents in real life world. For example, if you have your birth certificate, usually you do not give original birth certificate to everybody who asks for them. You create nice copy of it, and then you can show original birth certificate to ensure that this copy is correct, but then you give copies to everybody who needs copy of your birth certificate. And similarly about Java objects, when you work in distributed systems, it may be beneficial that you do not refer actual reference to original instance, but you create completely new instance, and then everybody is using their own proper clone or copy of this original object. I have not seen such needs in my professional programming experience, but I do not program 40 hours in a week, and therefore I cannot tell, but there may be some places where you need to create proper clone, and therefore you should know something about cloning and something about tuggable interfaces, and in this case about clonable interface. So that's it from me for now. Thank you for this guy who found implementation error for me here, otherwise it would take 10 more minutes for me to understand what is wrong there. And yeah, you can make this code a little bit shorter. For example, here source is used only once, so that means you can make this like this. But is it required and it still should work? I don't know. I usually use, for more complicated situations, I do not prefer to use temporary variables to understand better how exactly it works and to debug it better, because if I have several lines of code here, then I can jump line by line in the debugger, so I see exactly what is happening. But if I have a very long line here, things inside things inside things, then everything is just one single step for the debugger, so it's a little bit harder to debug. So, any questions or comments from you?